The James Webb Space Telescope has once again captivated the scientific community with a discovery that pushes the boundaries of what we thought was possible. With each new image and every piece of data it sends back to Earth, our understanding of the cosmos is being rewritten. Old models are being challenged, long-accepted theories are being re-examined, and new questions are emerging faster than they can be answered. In a particularly astonishing development, Webb has helped identify an object so massive, so vast in scale, that it redefines what we know about the architecture of the universe. This object, believed to be about 100 times larger than our own, Milky Way galaxy, represents not only an extraordinary feat of detection, but also a puzzle that has scientists across the globe rethinking how such a colossal structure could even exist. The story of this discovery begins with a broader context. Since July 11, 2022, when the James Webb Space Telescope released its very first image, it has been opening a window into parts of the universe never seen before. From distant exoplanets and early galaxies to the formation of stars and nebulae, each observation has painted a richer and more complex picture of the cosmos. The telescope's incredible sensitivity allows it to detect ancient light traveling billions of years across space, revealing celestial objects as they were shortly after the birth of the universe. Naturally, with this powerful tool scanning the skies, it was only a matter of time before it stumbled upon something truly extraordinary. That extraordinary object turned out to be a massive radio galaxy, now known as Alcionius. Unlike most galaxies that emit visible light, radio galaxies produce powerful radio frequency emissions. These signals, which span a frequency range from 10 milliRHz to 100 GHz, are typically generated by supermassive black holes located at their centers. These black holes do not merely consume matter, they also eject it. They shoot out colossal jets of charged particles that travel at nearly the speed of light, stretching far beyond the visible boundaries of the galaxy itself. These jets play a crucial role in redistributing matter, seeding the surrounding space with material that can one day coalesce into new stars and planets. Alcionius, however, is not just another radio galaxy. It is quite possibly the largest ever detected. Located roughly 3.5 billion light-years away from Earth, its scale is difficult to comprehend. According to measurements made by astronomers using Earth-based and spaceborne instruments, its full length spans approximately 16 million light-years. To put that in perspective, the Milky Way is about 100,000 light-years across. This makes Alcionius nearly 100 times larger, extending across a distance that would take light 16 million years to travel. If it were somehow visible to the naked eye in our night sky, it would appear as large as the full moon, despite being unimaginably far away. What makes this even more remarkable is the way Alcionius was discovered. It wasn't spotted in a dramatic burst of light or an obvious image. Instead, it was found through meticulous analysis of extremely faint radio signals picked up by LOFAR, the Low Frequency Array, a network of radio telescopes located across Europe. For years, astronomers had detected hints of an unusual source, but the signals were so weak that they were nearly indistinguishable from background noise. It took countless hours of data reprocessing and the use of new algorithms to finally isolate the patterns that confirmed the presence of this enormous galaxy. This method of retroactive discovery, going back through existing data to look for missed clues, has become an increasingly valuable tool in modern astronomy. Alcionius raises more questions than answers. First and foremost is the issue of its size. How did it grow to become so large? Many scientists initially speculated that its central black hole might be unusually powerful, driving more energetic jets that extended farther than those in other galaxies. But further analysis showed that Alcionius's black hole is actually quite average in terms of mass and energy output. Its total stellar mass and radioluminosity are also unremarkable compared to other giant radio galaxies. This paradox, that a galaxy so ordinary in many ways could produce such extraordinary features, has become a central mystery. Adding to the intrigue is its location within what astronomers call a cosmic void. These are vast regions of the universe that contain far less matter, fewer galaxies, less gas, and fewer stars than average. The Milky Way itself is located within one such void, known as the KBC void. Alcionius appears to reside within a similar low-density region, yet somehow it has developed radio jets that stretch millions of light-years across the void. As these jets interact with the sparse intergalactic medium, they don't move in straight lines. Instead, they bend and sway, creating vast arcs that some astronomers have described as resembling a slow cosmic dance. One curious detail is the apparent absence of moons in Alcionius. While moons are commonplace throughout the known universe, especially within our own galaxy, they have not yet been detected within this distant structure. This absence could suggest unique environmental conditions, or it may simply be a limitation of our current instruments. The galaxy's immense distance and the faintness of its features make detailed study extremely difficult. Still, scientists hold out hope that the James Webb Space Telescope will eventually provide deeper insights into its structure and composition. Interestingly, Alcionius doesn't seem to display any characteristics that would mark it as exceptional at first glance. Its radio brightness, the mass of its central black hole, and the stellar content of the galaxy all fall within normal ranges. This raises the possibility that there could be many more such giant galaxies out there, hiding in the data, waiting to be discovered through similar techniques. If that turns out to be the case, it could mean that our current models of galactic growth and evolution are missing key pieces of the puzzle. The implications of Alcionius's discovery stretch far beyond just one galaxy. It could help refine our understanding of the cosmic web, the vast interconnected structure of dark matter and gas filaments that link together galaxies and clusters across the universe. Structures like the Hercules Corona Borealis Great Wall, which stretches for 10 billion light-years and contains countless galaxies, are part of this larger network. Alcionius, with its immense jets and location within a cosmic void, could be an important clue in understanding how matter is distributed on the largest scales and how the universe has evolved since the Big Bang. As research continues, Alcionius may provide critical insights into the processes that govern galaxy formation, black hole activity, and the behavior of matter in the near-empty spaces between galaxy clusters. It may also help clarify how galaxies interact with the cosmic web and how massive structures grow in regions previously thought to be barren. In the end, the discovery of Alcionius is not just about one galaxy, it is about rethinking the universe itself. As we continue to peer deeper into the cosmos with advanced tools like the James Webb Space Telescope and future instruments yet to be launched, we are reminded that space is far more mysterious, complex, and surprising than we ever imagined. Alcionius stands as a monumental example of how much we still have to learn, and how much more there is to discover in the silent, star-filled expanse of the universe.